Hello, we are Spray. Um, I will speak about our irrigation system, starting with introduction and then continuing into experimentation and result and conclusion. First, our topic is construction of a water-saving automatic irrigation system, and our ultimate goal is to make farms eco-friendlier and more economical. We try to save the water using LoRa and MAP. LoRa is low power wide area network technology, and MAP is lowest soil moisture a plant can withstand without soil moisture, without water stress. So we observe the farm's data such as temperature and soil moisture through LoRa, and then we give water based on MAP. We conducted a small-scale experiment in a box. We choose green onion for our crops because our time is limited and they grow very quickly. And we used mist sprinkler rather than drip sprinklers to simulate the real green onion farm. Our system is same as last time. It consists of two Arduinos, one gateway, and a server side. Yeah. We use the temperature, humidity, and soil moisture sensors for checking farm's conditions. Each sensor is connected to an Arduino ADC port and can read sensor value using its library. And data collected from sensors and irrigation control packet communicates using LoRa. The server determines irrigation control by considering MAP and weather and soil moisture. The irrigate node is designed like this. If irrigate node receives the irrigation control packet, the Arduino instructs the relay switch 5 volt to operate water pump. And then we announce the experiment.
Let me introduce our experiment. We received a grow box that is 150 mm wide and 100 mm tall and 40 mm deep from our seniors. Before starting experiment, we divided our small farms into two sections for experimental and control group. On the left, we applied our system. When the soil moisture went down to a certain level determined by the maximum amount of water that soil could hold, our system delivered water. On the right side, as in the manual, we gave the plants 2 liters of water every week. The purpose of the experiment was to find out how much water we could save. All the conditions were constant except for the amount of water. The seeds and seedlings grew well in both areas. Fortunately, despite less water, all sections were healthy. Honestly, there is a critical defect in our system, that is the growth of unintentional plants. This one is presumed to be a sunflower because it had its seeds on its head, and this one is presumed to be a pepper because we found a pepper plastic seed bag in our farm. We even grew other crops while saving water. And now I will show you the result. The The left graph is the relationship between soil moisture and net. This graph relies on the type of soil and has a non-linear appearance. We defined our soil as a section between silt loam and silt. When the soil moisture went down 25%, we knew we had to water it up to 34%. And the right graph shows irrigation time and increased soil moisture estimated by experience. X-axis means the irrigation time and y-axis means increased soil moisture. This graph is the result of conducting linear regression based on data obtained by experiment. In other words, this task was to obtain the required irrigation time when the med limit was reached. InSpeak checks the sensor once a minute and produces this graph. A server refreshes data every 30 minutes. When the irrigation conditions are met and if rainfall is forecast, no irrigation is required or only insufficient water is irrigated that day. These bars represent the amount of water used both groups. We gave 8.2 liters of water to control group and our system consumed 7.4 liters. Our system saved about 10% water. Green onions have grown 6.1 inch in experimental group and 5.75 inch in control group. It is noticeable and when the September's rainfall is considered and it is applied to a real farm, only 62% can be used compared to control group. But now, due to limit of experiment, our experiment have been conducted indoors.
We made a homepage. Our homepage has information that helps users to understand our system. This is our homepage. Our homepage has a goal and our post and farm status. So if you click the farm status post, you can see our farm's humidity, temperature, and soil moisture. And back to the homepage. And you can enter the manual section. The manual section, if you enter the manual section, you can control our system and show our system's data. So this section is history about irrigation, and this data is you can see uses of water today and uses of water months. So using this data, you can easily check our system and predict water fee or water fields. And this section is you can see soil moisture and mud. And using this data, you can get a requirement irrigation time and requirement amount of water. So if our wet more than living wet, our system will irrigate. But the source water supplied by the rain is more than requirement water, our system will not irrigate. So if you can set irrigation time, just input a second, this input box. So if you set 10 seconds, can and set button. And our system. And this section is growth of stage of plants. This picture shows growth stage of corn, and a corn needs different water in each stage. So if you want to water requirement water, depending on corn stage, you input the corn age in this box. If corn age is 10 days, it calculates, and you can get the result. And you use this. You can irrigate, but depending on each stage of growth, using this result. And next, table 1 is total water use of manual system. So in previous presentation, we know that we can save 10% water. So the total water amount of corn is 55 inch. So if we save 10% water, we can save 6 billion gallon a year on regular on average Illinois farm. So we say considering the average price of tap water in US is 0.0015. So we can save about $9,000 a year. So if you use our system, you can increase convenience and saved price. This will kit to birth with one stone. And now on to our future effort. And first, we want to test our system on their farm. Second, we want to make a weather prediction algorithm. Third, we want to make a mobile application that helps user to control our system and view our system information. And we had also a fair share of shortcomings. And first, we failed to find that information that increased network coverage that would our system to apply to a wider farm. And second, if we add a fertilizer facility to our system could control the soil condition. And third, the ET. ET is the very important stuff about plants. So if our system considers the ET, the rate of growth will be very increased.